Alright, boys and girls, welcome back to the drive-thru for a nice, slow Monday jam. Here we are in 5.5, and we're going to have to go back to some of the stuff. I have a feeling it's going to be a long video, so we're going to get right to it. Okay? It says, Carlos and Clarita have found a way to represent the combinations of cats and dogs that satisfy their constraints, but they realize that they need to find combinations that satisfy all of their constraints simultaneously. So what that means is maybe it's possible for us to afford like 24 dogs. Like maybe that's a feasible amount of dogs to have as far as cost, but we don't have the space to have 24 dogs. So we need to have all of our restrictions or constraints satisfy each other. And that's really what we're going with this. So, begin by listing the system of inequalities you have written to represent the startup cost and space. So the startup cost, it was $32 for every, so let's put cost in green. It was $32 for each cat and $80 for each dog. And if you remember that we only had $1,280 saved up from our previous gig, okay? So that's your cost constraint. And then your area constraint, or space constraint, it was certainly 6C, and it was 24 square feet, 24 square feet per dog, and the most amount of space we had was 360 square feet. Okay? Now it says find at least 5 combinations of cats and dogs that would satisfy both of the constraints represented by this system. How do you know they work? So rather than testing them, let's just go right ahead to see how we would do this. Okay? So what I'm going to do is I'm going to go to the internet and I'm going to go to Desmos. You could also do this in your graphing calculator. You should be comfortable using both. And remember that we've been using cats as our X and dogs as our Y. So if I just go back to this real quick, 32X plus 80D is less than or equal to 1280. 32X plus, what was it? 80Y is, and then I go to down here, less than or equal to 1280. Okay, and then I'm going to add an equation, and that's going to be 6x plus 20. You sure it's 24? Okay, we'll go look. Is less than or equal to 360. Okay, now let me go back to this and make sure I'm right about that. Yeah, good. All right. Now, let's zoom out and see what we got. So, you have a red line, which is looks like your cost constraint, right? Yeah. And then you have a blue line, which looks like it is your area constraint. And then there's the purple zone. What's the purple zone represent?
Anywhere where the points touch, or not touch, but
the purple zone, that's the space that it works for both of them.
Except it can't go down into the negatives.
Correct. So we're only looking at the positive ones. So give me 5. Let me cut this. Snip it out of here. Okay, so it says find 5 combinations of cats and dogs that satisfy both constraints.
Well,
Give me some good ones.
well, it looks like we could have,
Some nice, easy ones.
looks like we can have about 15 dogs.
So 10, 10. Let's see. Where do you see 15? You saying 15, comma 0 or 0, comma 15?
Yeah.
Okay. Now for our cat lovers out there, give us the most amount of cats we can have.
I don't like that. 40.
40, comma 0. Oops. Oops. 40, comma 0. Okay. 10, 10.
We can have 10 cats and 0 dogs.
Okay, he's going with an easy one. 10 cats and 0 dogs.
Now we go for this point, which would be 6 and 8.
Okay, my bad. So how about 6 cats and 8 dogs? All of those work. Okay? Now, so we'll just put, let's see, that was 10, comma 10, 0, comma 15. What the heck? 0, 15, 10, comma 0, 0, comma 40, and 6, comma 10. All right. Find at least 5 combinations of cats and dogs that would satisfy one of the constraints, but not the other.
Oh, then you just have to look at, let's see, I think right that.
So, like right there.
Yeah, that'd be.
What is that? Like 1, comma 16? That would be 1. Okay. Whoops. Sorry. And okay, yeah, that's an easy one. Well, no, that doesn't satisfy the domain. So forget about that one. How about this one? Just make that one up. Or how about this one on the line? So that would be over 12, 14, 16, and up 11. Or even 10. How about 16, comma 10? 16 cats and 10 dogs. Ugh. How about 20 cats and 9 dogs? Yep. $20, comma 9. 30, comma 8. No, 30, comma 6. Okay, and honestly, that's enough. We get it. All right, shade the region on the coordinate that would represent the solution set of the system.
Well, it's kind of already shaded for us.
That's what's nice about Desmos, is Desmos has already done that for us.
Purple.
It's the purple region. Rewrite your systems of equalities to include the additional constraints for feeding time and pampering time. Okay, so now what are we going to do?
We gotta go back to Desmos.
We are going back to Desmos. We're going to go to there, and we're going to add another equation by hitting enter. Do you remember what our feeding? Let's pause that. So, if you remember, I guess we'll put this like in blue. The feeding and pampering that was 12C plus 20D is less than or equal to 8 hours. Now, was that all the same thing? No, that was just feeding. Sorry, that was feeding. I forgot. These are 2 different things, Cars. Remember that? And then what's the... You remember? Can you look back in your notes and tell me what the pampering was?
16C.
So we'll call this pink. $16C plus $20D is less than or equal to 480. So we're going to add those to Desmos. Okay? So 16x plus 20y is less than or equal to 480. Well, let me make this 12. Plus 20y, right?
Yeah.
And then on top of that, we're going to have 16x plus 20y is less than or equal to 480. And now you see all of our constraints. Okay? Oh, this is the one that's throwing it off. There we go. I'll zoom back in now. So you can see that only the real dark purple, and at this point it's a polygon, it's not a triangle. It goes to this line, and then to this line, and then to that line. Does that make sense, Cars?
Yes, it does.
Okay, so let me highlight all of that. And let's put it in our...
A lot of information. A lot of colors.
Alright. So, oh, don't do that. Alright, we're over our little technical difficulties there. Rewrite your systems. Okay, so now we've got all 4 lines on there. Find at least 5 combinations of cats and dogs that would satisfy all of the constraints. How do you know how these combinations work? Well, they satisfy all of the shaded areas is how we know. Okay? Give me 5, Carson.
With this point, 015 work?
015 still works.
Because it has to include that red space, right?
Yeah, it's got to be underneath every one of them. It's got to be in the dark purple region.
Okey-doke.
15, comma 10 works. So Carson's not just picking any. He's trying to pick the ones that'll give us the most amount of money.
Yes. 20, comma 8.
20 cats and 8 dogs.
And then there is 5, comma 9.
5, comma 9 certainly works.
And for all the cat lovers, 30, 0.
And 30, comma 0 for the cat lovers. Alright. This is where all the technical difficulties came in somehow. Alright, here we go. Find at least 5 combinations of cats and dogs that would satisfy some of the constraints, but not all of them. Okay? Actually, let me just do this. Okay, so I pasted that up there now. So, for instance, 0, comma 16 satisfies many of them, but not all of them. Okay? It's not underneath the blue line, which I believe is the pampering line, maybe. So let's just keep naming some. I don't think we need to do so many, but I'll do what they ask. So, like, how about 15, comma 14? Well, that only works... Sorry. 14, that's fine. 14, 14 works for some of them, but not for all of them. How about 0, comma 20? Works for some of them, but not for all of them. Let's go with 35, comma 5. Okay, and that's good enough. Shade a region of the coordinate grid that would represent the solution set to the system of inequalities consisting of all 4. Excellent, we have that. It's here, to here, to here, to here, and to here. It's a polygon. It's not a triangle anymore. It's a polygon, okay? Shade a region in quadrant 1 of the coordinate grid. Oh, that's what we just did. So we did that and that. Well, in number 8, I guess I would have also included all of the negative. So the difference between 8 and 9 is in 9, we've taken into consideration the domain. We can't have negative cats. We can't have negative dogs. Okay? So that's the difference between 8 and 9. All right, so that's pretty fast for this video, but if you followed along with that, I encourage you to use Desmos and or your graphing calculator to help you with this stuff. Now, what does this say? Read this out loud, Carson. No, just that.
Y is less than or equal to 1/5.
So, y is less than or equal to 1/5 x minus 4. Now, that you can pick a point. So let's pick this point 0, 0, Carson. It's an easy one to check. You get 0 is less than 0 minus 4. Is 0 less than negative 4? Is 0 less than negative 4?
No.
It is not. So this point fails, which means you shade on the other side of the line. However, when I teach this stuff, I think I use a little bit more of a common sense approach to it. So Carson, once again, can you read this out loud?
Y is less than.
Y is less than 1/5 x minus 4. Well, less than is below. So you just shade below. If you get it in terms of y, that's much easier, okay? So which side of this line are we going to be on? Well, read it out loud.
Y is greater than.
Y is greater than, and greater than is above. It's y, so it's not right and left, it's up and down. So that's above, but above in this case is to the right. So you might have to practice that, but guess what? If you're not sure whether or not you got it right, just test an easy point. Once again, a very easy point is 0, 0. So if you test the point 0, 0, is 0 bigger than or equal to 0 plus 5? 0 is bigger than or equal to 5? No, it fails. So that means this side doesn't work, so the other side has to work. Got it? Correct. So now that you get to these, you tell me, is this y is greater than, y is greater than or equal to, y is less than, or y is less than or equal to?
Less than.
Y is less than or equal to, because it's not a dotted line, it's a filled-in line. Do you understand the difference?
Yeah.
Okay, now, what's the y-intercept of this line?
Looks like 7.
10, 9, 8. Yep, so b equals 7. Okay, if I go over 1, I go down 1, over 1, down 1, over 1, down 1, over... No, not 1/2. What's down 1 indicate?
1, just 1.
Is it positive or negative?
Negative.
Whoops. So our slope is negative 1. So our equation is y is less than or equal to negative 1x plus 7. Okay? What's the y-intercept in this one? Okay, so it's y is greater than or equal to. Sorry, I skipped that. What is the y-intercept, Carson?
Negative 4.
B is negative 4. Now I go over 1, up 2, over 1, up 2, over 1, up 2.
Now it's 1.
Nope. 2. Over 1, up 2. Okay? So, y is greater than... Oh, I got this wrong. What's wrong about it? That. It's not equal to because it's a dotted line. So y is greater than 2x. Sorry, I already have the 2 done. 2x minus 4. A lot of stuff going on. Keeping it under 20, though. Come find me. I'm sure you have questions. Let me do some more of these for homework, okay? I'll add them to the list. Boom!